I'm Regina Bures. I serve as the Scientific Program Director for NHLBI's Biodata Catalyst. I also recently moved into the role of NHLBI's Data Science Strategist. NHLBI initiated Biodata Catalyst several years ago to address the needs of the heart, lung, blood, and sleep disorders research community. BDC is a cloud-based ecosystem offering researchers data, analytic tools, applications, and workflows in secure workplaces. It's a community where researchers can find, access, share, store, and analyze heart, lung, blood, and sleep data, as well as an NHLBI data repository where researchers share scientific data from NHLBI-funded research so that they and others can reproduce findings and reuse data to advance science. By increasing access to NHLBI's data and innovative analytic capabilities, Biodata Catalyst accelerates reproducible biomedical research to drive scientific advances that can help prevent, diagnose, and treat heart, lung, blood, and sleep diseases, disorders, and conditions. The ultimate goal of BDC is to facilitate the reuse of heart, lung, blood, and sleep data to drive scientific discovery and ultimately improve the lives of patients. In doing this, BDC actively collaborates with multiple data resources within NHLBI as well as across NIH. In September of 2023, the Global Alliance for Genomics and Health, otherwise known as GA4GH, announced that NHLBI's Biodata Catalyst was named one of 7 new GA4GH driver projects. The BDC driver project builds on the former TopMed driver project, expanding to incorporate multimodal data and seeking greater integration into the heart, lung, blood, and sleep data ecosystem, as well as international interoperability. BDC also serves as an active contributor to the NIH Cloud Platform Interoperability Driver Project. GA4GH driver projects are globally recognized initiatives that help build and implement standards, tools, and frameworks. They give voice to the broader genomics and health data community and ensure that their products serve real needs, bringing together genomics projects working on data infrastructure, management, analysis, and sharing. GA4GH communities of interest and work streams seek to bridge the divide between technical developers and clinical practitioners. Communities of interest serve a forum for researchers, clinicians, and technical experts in specific domains, such as cancer, rare diseases, and infectious disease, to help define, discuss, and advance use cases that could involve GA4GH products. GA4GH work streams help create new global standards and frameworks for responsible genomic and health data use. An evaluation of a platform's potential contribution to the GA4GH work streams, as well as their ability to expand GA4GH's global geographic footprint, are components of the review process. All GA4GH projects have a mission and goals that depend on real-world genomic interoperability. So it's a very big deal to have BDC included, as well as recognition of our potential to help create and implement new data standards in the future. Another highlight this year for BDC was the release of 6 clinical data sets related to sickle cell disease. Sickle cell anemia is one of the most common genetic blood disorders in the United States. BDC hopes to help advance sickle cell disease research by hosting key data sets in its cloud-based ecosystem. We host several data sets that contain genomic data within TopMed, and in the past year, 6 clinical data sets related to sickle cell have been added. BDC offers the sickle cell research community an improved ability to browse the data and facilitates reproducibility. Researchers can collaborate in cloud-based workspaces, create cohorts, and use a variety of tools and workflows to reuse the data, conducting secondary analyses of existing data to reproduce existing findings, as well as to unveil new insights. Researchers are also able to combine BDC-hosted data with data that they bring to the ecosystem themselves. This is the Bring Your Own Data feature of Biodata Catalyst. BDC is increasing researchers' access to key sickle cell data and providing them with enhanced analysis and collaborative capabilities to advance sickle cell disease research for improved treatments to help improve the lives of people living with sickle cell disease. These are the current 6 clinical data sets available in Biodata Catalyst, some of which also have associated genomic data from TopMed and biospecimen data available via BioLink. In September, Biodata Catalyst published a blog and hosted community hours focusing on these data sets and featuring some of the sickle cell disease research that has been conducted on BDC. A recording from those community hours is available to you, so please visit our YouTube channel. So finally, I'd like to close by thanking those who make Biodata Catalyst possible for their work in 2023 and their continued commitment into 2024. This diagram represents the underlying motivation for BDC. We at NHLBI and on the BDC team are always thinking about the who and the why, the heart, lung, blood, and sleep researchers and the patients they serve, and whose lives we hope to ultimately improve. I'd like to take a moment to thank all of the people in the Biodata Catalyst community, like yourselves, who make our community richer. You don't have to be an active research scientist to belong to or contribute to the community. We appreciate your membership in the community and support for the BDC mission, no matter where in the ecosystem you are. If you'd like to become more active in the community, please contact us. The Biodata Catalyst team is here to help. Finally, I'd like to particularly thank the BDC team, the various organizations, including but not limited to NHLBI, as well as our consortium organizations, our passionate researchers and fellows, our data teams, program managers, project leaders, user specialists, and all the administrators without whom BDC would not be possible. Thank you, and I look forward to working with you all in 2024.